G'day everyone, just building another system for a guy, and it's at a stage where I can do a video that might be beneficial for a few people. It's on the Shurflo pumps. I get asked a lot of the same questions, or people come to me with the same problems. So I thought let's do a video and explain a few things here. So the Shurflo pump, this is a demand pump, so it's got the pressure switch on the top there. Demand means the water's on when we want it and it's off when we don't, by turning a tap on and off or kinking our hoses. The other type of pump is a bypass, and that doesn't have a pressure switch. That pump runs constant. So in the case of a bypass pump, we kink our hose, the pump's still running, but it's constantly pumping the same water around and around inside the head, and what that can do is build up heat, and that heat can cause the diaphragm to perforate and water to then run back in, corrode out the windings, rust up the bearings, buy a new pump. How do these pumps run? In here is a plate, and the plate sort of wobbles like this, right? And it's got like valves on it, and there's a seal that comes through here, neoprene, or we'll say a type of rubber seal. As the water gets hot, it heats that up and then it perforates. So that's the cause of the failure for them. The demand pumps, the pressure switches fail. Again, it's not a fault of the pump, it's how we use them or how we've set them up. They're both really good pumps. They are very widely used in industry, and this particular pump is very widely used in our industry. So it's a 1.8 GPM demand, and let's talk about how to set them up. So we're going to assume that you've plumbed it in, you've got your water coming in and your water coming out, and that the hoses are at least the high diameter that Shurflo specify. We've got to assume they know a bit more about the pump they've designed than what we do. Don't run 8mm tubing, it's too restrictive. I've seen 8mm tubing used quite a bit out of the pump. It's too small. So it's 8mm outside, what's your inside? This is 16mm, so I know it's got 12mm internal, and that's within the specs that Shurflo recommend. So I know I don't have an issue caused by the plumbing here. The pressure switch has an adjustment screw on it right here. Now it's a hex screw or Allen key, and it's either a 1.5 or a 2mm, somewhere around there. And you just turn it clockwise or anti-clockwise. So when you first put your pump in, you've got your pump running, it's pumping water out. You then want to connect up your hose runs that you use and put a brush on the end. And you shouldn't hear the motor change. It should be still smooth running and constant. If it's turning on and off, or it's turning off very quickly, or you're hearing, this, or, worse, it's not smooth, you need to adjust that pressure switch until it becomes smooth running, and it's just a constant run. And I'd probably say let it run for 2 minutes and make sure it doesn't turn off at any point during that. Once you've got that right, kink your hose. You want to count to about 3, and then you want to hear pump turns off. So you hear a click and the pump turns off, and you know that you're set right. If your pump comes on while it's kinked, you've got a leak in your hose somewhere between where it leaves the pump and where you've kinked your hose. So that then becomes an issue of find the water leak in your hose. But yeah, make sure you've got that pressure switch set correctly, and the pump will serve you well. It's quite simple to do, but it's not set and forget. There's a few things that can affect that adjustment. You've got hot and cold weather, so summer and winter, the water viscosity changes, and the pump needs to be adjusted according. Battery's full. You've also got different hose lengths, so a lot of people will set it up on their hose run, and then they'll end up at a bigger job and they'll put an extra hose on there, and then wonder why the pump stopped working. They've burned out the pressure switch because it was set for the hose run that you normally use, not that extra load you've put on. So the longer the hose, the more pressure it takes to overcome the resistance of the extra hose. So you need to come back and check this pressure switch again. They burn out sort of within a job in some cases if they're not set correctly. The other thing is vibration. It doesn't happen often. I've had a pump go out of spec twice because of vibration. So yeah, just keep an eye on them and make sure they're going good. So why do the pressure switches fail? Here's a pressure switch. This is a failed one. How do they work? Well, the pressure builds up on this little button here and pushes it in. It does take a lot of pressure, and it presses on a switch and turns it off. So this is the part that actually fails inside them. So that's when the pump's running, and then the pump turns off. So this is the part that actually burns out, and it happens that much that I carry bulk of these. I'm replacing them all the time for people. Why do they burn out? I don't know if you've ever seen what happens when you short out a car battery. The arc is very aggressive, and what it does, it etches through the thin metal. Now this is quite thick compared to what's inside. What's inside is two pieces of metal that, like a hair clip, I guess. You've got the try and find where my fingers are. Two pieces of metal that just click like that, only thin. It just arcs straight through them, just vaporizes them. So that's why they fail. So what do I do to overcome that? I still use these pumps, but I run an external pressure switch. So what I've done is take the load away from that and moved it to something more durable. Now this does exactly the same thing. It senses the pressure, and it still needs to be adjusted by this pressure switch. What makes it more durable is I'm not using this thin little relay. I'm actually using an automotive type 40 amp relay. Now those pumps, they specify them as 7, how many amps? 7 amps. I'm yet to see one running at 7 amps. I'm reading at least 10 to 12. I have seen them up at 15 amps at some times. So 40 amp, I know I've got plenty of power handling capacity of that. And this is where a lot of people do ask me the question, well, how do you hook it all up? Electrics isn't their thing. Well, it's not as complicated as what it might seem. That's a wiring diagram, but I'll break that down into simple terms. I do recommend buying a relay base or a relay connector, or you can get ones like this that I've got to wire up myself. But it's much easier to change a relay when it burns out in this way than the other way. So, you know, if this one fails, you just pull it out, you throw it in the bin, you grab another one, and you press it in, and you're back in business. It's as simple as that. And they do store nicely in the glove compartment. So how do you wire them up? If you're not familiar with the relay, they do have numbers on the bottom of them on each pin. And generally on the back of the packet it tells you what each pin is. If not, Google will tell you they're all the same numbering. So let's have a look at hooking it up. So what does a relay do like this? It's an electric relay, not a manual relay. So you've got two circuits, a high power and a low power. The high power circuit is what powers the pump. The low power circuit is what turns it on and off. So we'll start with the high power pump circuit to the pump. So 12 volt battery, our positive, we're going to run a 20 amp cable between that and a fuse. We then go from the fuse into the relay into pin number 30. So that's the 12 volt in. And then we go from pin 87 out to the pump. So that's all the positive. And then from the pump, we take our black negative wire and we run that back to the battery. That is our pumps controlling, our pump's power. We now go to the switch side that turns it on and off. So we're going to start from the positive on the battery again, running a new line. Now this can be a 10 or a 15 amp cable, doesn't need to be 20 amps. We come out of the battery and we go up into a switch. We come out of the switch and we go into the pressure sensor. We come out of the pressure sensor and it goes into pin 86 on the relay, which is the switching pin. And then we run a black wire from pin 85 to the negative of the battery. And that is how we power it. So you can see we've got two circuits happening there. The high powered circuit that comes through and puts power to the pump, the low power that turns this on or off. So the power flows through here when it's on. If you turn this side off, the power doesn't come through anymore, the pump can't run. So we've taken the load away from this little switch here and moved it to a 40 amp relay that's easy to replace. We don't have to pull anything to bits. We just pull it out of its connector and then just put the new one back in its place. So I found that to be very durable. There's no modifications to the pump. As you can see, that pressure switch is still in place and is still fully functional. We're just running it off this one, which will turn off at a lower pressure than what that does. You still need to make sure you do keep an eye on it. If you're running extra lengths of hose, you do make the adjustment needed. Yeah, should something go wrong, you're just going to replace the relay, which is very simple to do. You can put in a wireless remote. So let's say you're running a bypass pump that won't turn off, it continuously pumps. You can turn it on and off by a remote. But you got to keep in mind that if someone parks on your hose, your pump hasn't stopped, it's automatically in bypass, it's going to start to build up heat inside the pump head, and over time it is going to fail. So these are, again, this one's quite simple to install. I know a lot of people use these. Personally, I'm not a fan. They don't have a very good range. If you're on one side of the building and this is on the other, they're very erratic at best. My other system, my big system, I've got a range of 5 kilometres. So far I've been able to work 3 kilometres going through multiple buildings. I've actually been for walks around the neighbourhood and got many streets away and then the other side of the shopping centre, and it still worked flawlessly. But big controls, big units, not as convenient as something like this, but these are very simple to put in. Positive and negative from your battery, and positive and negative to your pump. So there's a couple of different options. I hope that's helped some people with why they keep having trouble with the pressure switches, how to wire up an external through a relay for a more durable setup. Yeah.